Good morning, students. Today we shall learn about solutions to inequalities with two variables. All right. So far we have done and we have found out the solutions of inequalities with one variable along with the representation of the solutions on a real graph. Okay. So today we'll see the solutions to inequalities with two variables. So let's start the topic. We know that a linear equations with two variables has infinitely many ordered pair solutions that form a line when graphed, that you have seen in your earlier classes, that is in class 9th standard. As well as in class 10th, a linear inequality with two variables, on the other hand, has a solution set consisting of a region that defines half of the plane. So if you look at this particular diagram, a Cartesian plane is drawn here. So when we talk about representing a linear inequality in two variables, we always consider an equations, and first of all we need to find a different solutions of that equations and then drawing the equation line on the given Cartesian plane. So by drawing it, you'll get two planes, two regions. Number first region is this, number second is this. Okay, so the given Cartesian plane or the plane is divided into two sections, the first half and the second half. All right, so this is the upper one, this one is the lower one. Okay, this one is upper, this one is lower. When we are having a graph like this is the first half, this is the second half. Okay, so we call it as a half planes. Linear equations y is equals to 3x by 2 plus 3 and y is less than equals to 3x by 2 plus 3. All right, so equations out of this inequations is this one. So for the first one, for the equation, this graph is satisfied, and for the second one, this is satisfied. All right, so the shaded part is the second region. That means if I place the value of 0 and 0 as the ordered pair, if we take for the value of x and y, what we get is 0 less than equals to 0 by 2 plus 3. That becomes 0 is less than equals to 3. If 0 is less than equals to 3, that means what? The ordered pair which we have taken, that is 0, 0, satisfies the given inequations. So the reason will be the second reason, because if I have taken this point, the origin, it satisfies the origin points. So the second reason will be the shaded part. For the inequality, the line defines the boundary of the region that is shaded. This indicates that any ordered pair in the shaded region, including the boundary line, will satisfy the inequality. To see that this is the case, choose a few test points and substitute them into the inequality. So this is the test points, how to solve the given particular inequation algebraically by trial and error method. So this first test point is 0, 0. Putting into the inequation y less than equals to 3 by 2x plus 3, you get 0 less than equals to 3. If you take 2 and 1 as the ordered pair, 1 is less than equals to 6. So this also satisfies, and this also satisfies. Also, we can see that ordered pairs outside the shaded region do not solve the linear inequality. By looking at the graph here, if I take points which is not in the shaded region, I mean to take the points like minus 3 and 4, this will not satisfy the given equation. Let's see. The point which we have taken here is minus 2 and 3. So it will be like 3 is not less than equal to 0. So this will not satisfy. That means the solution set is not above the line, it is below the line. Okay. The graph of the solution set to a linear inequality is always a region. However, the boundary may not always be included in that set. In the previous example, the line was part of the solution set because the or equal to, that is more than equal to or less than or equal to, part of the inclusive inequality. That means it is slack inequalities. If given a strict inequality, that is less than, we would then use a dashed line to indicate that those points are not included in the solution set. So what it means here, suppose the inequation is given like this. This is for a strict inequality where only less than sign is used, and this one is inclusive boundary, that is less than and equal to is used. So for this inequation, we have to use a dark line, okay, that means the solution is included within the line also. Whereas in this case, for the strict inequality, or we call it non-inclusive boundary, for this we have to use a dashed line or dotted lines. That means the solution set, all the solution sets on this given line is not included. It is less than that. Let's talk about a different example here. Graph the solution set y more than minus 3x plus 1. So if you see here, this is a strict non-inclusive inequality. For that case, first of all, we have to get the solutions by just equating y equals to minus 3x plus 1, right? And then finding the different solutions of x and y and then plotting it on the graph. So it looks like this. So if you see this dotted line or dashed line, that means what? The reason will be, if I place 0, 0 in this given inequation, 0 more than 0 plus 1. 0 is more than 1, that is not possible. That means the shaded part will be above the given line, not below this line, right? This is the shaded part. So test points are like this. 0 is not like more than 1. So in that case, the shaded region is this one. I hope this is clear to you, all of you, class. And for more problems, you can always join the virtual class for more clarity. And if you have any doubts, you can ask in your virtual classroom. That's all from today. Thank you.